Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. Today's lesson will show you how to recreate this very nice building here by big architects. It's called the VM house in Copenhagen. I have here a look at the very striking facade with triangular balconies of random sizes. I have here as well another look at the same building from the side. And as you can see, it's very similar to what I have created here in Revit. To be fair, you can perfectly recreate this manually in Revit by drawing each and every balconies one by one, but that takes a lot of time. So today I'll show you how to turn from this, which is a simple mass that has balconies with identical size, to something much more interesting like this using a simple Dynamo script. If I open Dynamo now, I can just run it once like that, and it should very quickly randomize the sizes of these balconies to give the facade a much more interesting look. By the way, if you are new to this channel, make sure to subscribe now because we do tutorials like this every single day. Okay, let's get started with Revit and Dynamo. I will firstly close this project down, including this one here. We will recreate this mass straight away. The template to go from is obviously conceptual mass. Let's go to New, Conceptual Mass, Metric Mass. And now we can quickly recreate the footprint of the building. Let's go to level 1 now. I can now draw a model line starting from the origin point. Make sure I'm drawing on a work plane, by the way. And let's go this way by 15 meters. Also make sure you turn off 3D snapping as well. And then do 15 meters. We can now rotate this line around this center point by 30 degrees. Next step, I can mirror it to the other side now, and change the second line's length to maybe 60 meters. That's much longer than the other one. Let's do this maybe 45 instead. Perfect. I can now select both lines and copy them up this way. And then we can use two more lines to make sure they form a closed nice loop. Switching to 3D now. I can now select the whole thing and do create form. Let's bring it a bit higher up like this, and then change to the south elevation. We can now start drawing a single line like this, and then extend it up to make another closed loop as well. Go into 3D now. I can see that this can now become a form. I can then make sure it intersects the whole thing below it, and change the new form into a void. Here we go. That gives me roughly the same shape as the real building there. Next step, let's create a component for our balcony unit, this triangle thing there. We can now go to File, New, Family, and go for curtain panel pattern based. The first thing to define here is the thickness of the balcony slab. Let's firstly select here and hide this grid just for now. It may take a bit trial and errors, but I'm guessing this will be the bottom line of one single cell on the facade. We can now go and drop 2 points on it. Make sure you're drawing new points on face and do 1 point here, 1 point there. I can now select those two and make a line connecting them like this. I can now save this as balcony 1 and then simply load it back into the mass family here. Let's put it to use. I can now select those two faces of the mass and do divide surface. We can now make sure each cell in those faces is 3 meters by 3 meters. So to do so, I can change the U grid to fixed distance of 3 meters, and then the same for the V grid. Here we go. Now there are partial panels along the bottom. For the first phase, click on this icon to change the grid justification and move the origin point to here. I can now do the same for the second phase, but this time move this point to there. That will make sure my grids on these surfaces match in position and orientation. We can now select them both and tell them to use the new curtain panel type, balcony 1. It's a bit hard to see, but if you can look closely here, this panel, for example, is bottom face there, but now the new line I have is up here. That means we have picked the right edge for our balcony slab. We can now go back to the panel family now. Select those 2 points and change their measurement type to segment length. If I now get this first point there, the length is now 2 meters 700, and that's because it's measuring from this point to this other end. I actually want this other length from this side instead, so let me change this measure from parameter to end. That gives you 300. For the second point, that seems to be correct more or less already, so I can just leave it like that. If I now get those points again together, I can now change this to 150 mil, which is the thickness of our balcony slab. I can now turn this into a parameter as well. Let's call this slab thickness. Next step, we can select this line now and make it a reference line. I can now drop on it a new reference point, like this. Moving on, I can now drop on this new point, yet another new point. Make sure you set the work plane to be this horizontal plane right there. And now drop the new point right on top. Dismiss the warning about identical points. I can now get the last point I placed and then move it up. The distance between here and here will be the overhang amount of our balcony. In other words, the distance between here, the facade, and the furthest point on the balcony itself. To control it better, I can now maybe set it to be an initial value of 4 meters and make this into a parameter as well. Call this overhang now and make sure that's instance because we want to change this for each balcony later on. Click OK, and now I'm free to connect this point to this point on the left there. And then the same from this point to the point on the right. Get them both, those lines, and I can now make them also reference lines. It's time now to put in some details for our slab. If you look at this other reference image, you can see the slab has this kind of double edge profile around this perimeter. We can now create this in this family as a simple sweep. For the profile, I can go to File, New, Family, and choose to make a generic model adaptive. In here, I can drop in the first point, select it, make it adaptive, and start drawing just a test rectangle on one of its faces. Let's go to Model Line, Rectangle on the work plane, and set the work plane to maybe this horizontal one. I can then draw a rectangle from this point going this way. Let's now save this as Profile Slab, and then load this back into the balcony panel family. I can now start placing it on a face and try to place it here on this curve. As you can see, because this is an adaptive component, it has oriented itself according to the host curve. I can even see now that the rectangle is at the right orientation, and that means I can now simply go back there into this family and make it into a proper profile family for the slab. Let's get this line here, make sure this is 200, and the other distance also 200 as well. For the double edge effect, I can now go and draw some new lines simply by offsetting one of those lines by 20 millimeters. Let's go for this one, and this one. We can now split this line there and trim the rest of lines into a closed loop. Now it's ready to go back into the other family, balcony 1. If I now click on this and then select those 2 reference lines, I can now do Create Form, and my profile for the slab edge is complete. The next thing to create, if we go back to the image now, is this mesh panel for the railing. We can follow the same process, and to save time, I will go back to this family here and save it as a new family. We can call this one Profile Mesh. And now we can simply edit those lines to get the other profile. I will now draw a second rectangle like this. Delete the other one. Make sure this distance is 150, the thickness of our slab, and the depth can be 20. I can now move those lines down like this, and then extend this single one up to add in the height of our railing. That will be 150 plus 1100. Save it now, and I can now load this back into the balcony family. This is also an adaptive component, so I can place it like this as well, just like with the other one. And you can see it has oriented itself properly. I can now select it like that, get this reference line and this other one, and then do create form. There's a gap there, however, but that's easy to fix. This is happening because my profile is actually thicker than the slab. Let's go back here to this profile family and then move those lines up by 50 mil. Bring this back to the family now. And that's neat. Next thing to create is the railing, or this handrail here. You guessed it, we can use the same process. So I can go to this mesh railing family now and save this as a new profile family. Just call this profile handrail. And I know now, this is the top of my mesh panel, so I can just draw a new profile from this point going this way. And then delete whatever already there. Make sure from this to there is only 100. And this thickness can be 20, that's fine. I can now save this, bring it into the balcony family again. And now it's a bit hard to place because the mesh panel is in the way. Let me get it like this and hide it for now. Same with the slab edge. Now it's clear, I can now go to create component and place my profile for the handrail right here. Get the profile, get those curves, and do create form again. Now, to avoid seeing those profiles in the project, I can now get them like this, and then untick this visible box under the properties. You still see them now, but they won't show up in the project. We can now reset the view and start giving materials to those objects. Let's go for the mesh one first. With this one, I can go to here, duplicate this, call this mesh, go to appearance and do replace asset. In here, we can search for mesh and then get one from those options. Maybe we can go for this one here. I just have to double click to insert it and then close this window. It's here now, but because it's following a torus, it's hard to see. We can now set this to be a cube. And you can see now that's the same type of mesh we have in the reference image. Let's now change to the graphics tab and give it some transparency of maybe 50%. Here we go. I can also give it a surface pattern. So if we go to surface pattern here, go to model, make a new pattern, call this one mesh, and do a crosshatch of maybe 30 by 30 mil. Now it's there. For the handrail, let's do a timber material. Let's go to here now. Duplicate this, call this new one handrail. Go to appearance again, replace asset. And in here I can just go to physical asset, wood. Maybe this one is good for now. Make sure you use render appearance for the shading and do OK. Very nice. That should be okay for now. Let's now create the slab of our balcony. We can now turn this way. And I will hide the handrail and the mesh to get a better look. To create the boundary of our slab, let's put in here 2 more points. Make sure you place them on face. And the first one can be along this edge. When you select it, we have now the option to host it by intersection. Click on that now. And select this face here of the profile. That will make sure it's always there where the profile intersects this reference line. We can now do the same on this other side. Here we go. I can now get this point there, along with the other one here, and then create a new line between them. Make that line reference line. Moving on, we can create another point here, just by clicking where it should be. Before we move on, I want to make sure this point flexes properly. So if I now get this point there and move it down, you can see that it does. We can now get this and connect it with this other point here by another reference line, and do the same on this other side. If I now select this one here, I have 3 lines interconnected, which is perfect for me to do grade form. It's going up by default, but I can now change the positive offset to be 150, and this can be 0. My slab is in now, and it slots nicely into the space left by its edge. Alright, the final thing to grade here is this cable. And to make it happen properly, we need to have this connector element at the far end of our balcony. Let's make this using another adaptive component. I can actually reuse this family here. Just do File, Save As, and call this one connector. We can now delete those lines, go to Reference Rectangle, and set the work plane to be this vertical one here. I can now draw a quick rectangle like this. Make sure the size is maybe 50 by 50. We can now move it down slightly. And also this way as well. With that done, I can now get those lines and do grade form. Let's save it first and test it in the balcony family. Again, a bit hard to place things now, so I can hide those 2 elements just for clarity. And also this one here. We are now free to do component and place it maybe there. I want to place it roughly at the far end of the balcony, so this parameter I can do maybe 0.8, and now it's there. We now need the same one on the other side, so let's do grade similar and place this one here. The second item, however, you can see now that it's coming to the wrong side. It's going up from the slab, and that means you need to make it as a separate family. We can go to Edit Family now and move this line to the other side of the reference point. So firstly, align them together and then move those lines away. I can now save this as connector 3 and bring it back into the balcony. Select this now, I can change this to the new type, and now it's on the right side. If I now reset the view and take away the mesh, you can see that this connector element has to extend a bit more to meet the inner face of the slab edge. Let's edit family and make that happen. So this can go this way by 100, but then it has to go back by maybe another 100. Let's see how it looks like. Nice. We can do the same now for this other one. So 100 this way, 100 that way. Bring it back, and there you have them. It's time now to create the cables for our balconies. Now you may ask why I have to do 2 connectors. Isn't that wrong because in here I only have 1 connector per balcony? Yes and no. If you look closely, this balcony here has a connector on the left and this one has the connector on the right. It depends on the triangular shape of each balcony. If you consider this the left side of the balcony and this is the right side, this sharp point here, if it's more towards the right side, then the balcony will have a left cable. However, if the balcony is leaning to the left side, like this one does there, the cable will be placed on the right side. Otherwise, this cable can clash with the balcony railing, and that's not nice. That's why I have to do 2, and then we can choose when to turn them on or off, depending on the situation of each balcony. So, just like with 2 connectors, I cannot do 2 cables. Let's create now a reference line on face and turn on 3D snapping. No need to do chain for now. I can now go from this point, going all the way to here. Second line, same thing happens, but now on this other side. All the way to there. You can of course make this connector a bit more detailed, just like in the image. But for now, for speed, I will make it roughly like so. Next step, we need to create the geometry of our cable. To do so, I can now drop in here 4 more points. So 1, 2, 3, and 4. We can now draw 4 more reference circles, each on each point's reference plane. Let's go and set the first one now. First one like that. Make this dimension permanent for now as well. And do it 3 more times. Okay, I can now select the 4 radial dimensions and turn them into the same parameter, cable radius. That's a bit big for a cable. Let's make it 10. And I will hide dimensions just for now. We can now select the first 2 circles on the first cable and do create form. Let's do the same for the second cable. Now I can select this point and move it all the way there. Get the other one as well and move it all the way here. You can drag them like I did, or another way is this, get the point and change this parameter to maybe 0 for this and 1 for this other one. Here we go. Now, to turn them on or off, I need to get them some visibility parameters. So let me get this connector and this cable. Under visible, let's get this to be a new parameter. Left cable is going to be, make it instant as well, and do OK. Do the same thing here for right cable. Instant as well, and OK. Now, to determine which cable is on and visible, we need the balcony family to check its hosting parameter, which is the parameter of this point here. If this is 0.5, the point will be at the middle. If it's less than 0.5, the point is here on the left side of the balcony. And if it's more than 0.5, it will be on the right side. Based on that fact, I can go to family types now. Under left cable, let's use a formula to drive this value of this box. For that formula, however, we need to first make this a parameter. Let's call this param1 and make it instance. Go to the family types now. I can then do param1 is less than 0.5. And you can see straight away that's grayed out, but it's a yes. This one right cable, it should be the opposite of the left cable parameter. I can just do not left cable. So if this was true, this will be false. If I somehow change this to 0.7, this will become false, and I will make it true here. If I do OK now, you will see. Here we go. This is just a bit more gray than the other one. That's how we know it's going to be turned off in the project. Alright, this panel for the balcony is ready now. I can now reset the view and bring this into the project. Family 9, that's a massing component. Overwrite everything now. And look at that. Lots of balconies in one go. Anyway, it's a bit much because I can see now in the reference image, we have one balcony and then one bay with a balcony and then repeat. That means this pattern has to change from rectangle to checkerboard. Here we go. There's a small problem though, because I made this balcony family wrongly for this pattern here. I should have changed the pattern to checkerboard at the beginning and then make the panel for this type of pattern. Now there's no way I can use this for that. Luckily, I did the same for this pattern already in the test project that I showed at the beginning, so let me just open that panel now. It's exactly the same process I used for this one. The only difference is, at the beginning of doing this, I did remember to select the grid and change this to checkerboard. That means if I now load this back into my mass family, I can now get on this pattern there and make it use VM panel. Here we go. Now you have a balcony every other rectangle in the system. We can do the same here now. Change this to checkerboard using VM panel. And that's it. It's a bit tricky at this corner here, so we have to manually take out some panels we don't want. Just manually select and delete them, but that was quick to do anyway. If I now select one of the balcony units, you can see now under properties, I can change this overhang to maybe something else, and also change this parameter 1 to adjust which way it's going to lean. If I go for 0.75 now, you can see now instead of leaning to the left, it's now leaning to the right, and the cable position has changed accordingly as well. Anyway, as I said at the beginning, this is tedious to do for hundreds of balconies like this. So to get quickly an interesting effect on this facade, we can use Dynamo. Let's go to Manage, open Dynamo. By the way, if you are new to Dynamo, no need to worry, because I have this same script as a download link in the video description for you anyway. So if you really want to, just download that and run that. We will however now see how quickly we can build this script. It's quite simple, it won't take long. Let's go to New now. And we can start with selecting our curtain panels there. I can now right click and search for family types. In here, just choose the curtain panel family. VM panel is going to be, and do all elements of family types. Connect this to there. And you can see now it's returning 197 items, which is a bit more than what I needed, because you can see some balconies are partially graded along the boundary of the facade. That doesn't make sense in this case, so let me select them both and change the border tile to empty. That means some panels are clashing again, so let me remove some of them as well. Okay, if I now go to here and run this again, we will have fewer panels, only 173. Now, here's the plan. We want to vary the overhang amount and the parameter 1 parameter of each balcony to give a randomized effect. Let's first define what we want to be the overhang. I can now right click here and choose range. This will give you a number range from a start value, an end value, and a step. Let's double click here to bring up this code block and type in here 4000 for 4 meters. Enter and then do 4500, 4 meters and a half. And for the step, let's do 100 mil. I can now connect them to here like that. Run this, and it will give me here this number list from 4 meters to 4 meters and a half. You can go for either more or fewer values as you like, but for now these are enough. For the param1 parameter, we can copy those two nodes. But now the start should be 0 and the end should be 1. For the step, let's do 0.1. Run this now, and it gives you another list. We can now simply get those values into our panels. To do that, let's get the number of panels first. I can do count, and that should give me 173. We next have to resolve the differences in numbers of items. We have here hundreds of panels, but only 6 values for the overhang and 11 values for param1. To make sure each panel has at least 1 value from here and 1 value from there, I need to repeat those two lists until they have at least 173 items. We can now right click and do cycle. This node will repeat this list by this amount. We can just use this count for the amount. Run this, and you have here more than 1000 values. Don't worry, we will discard what we don't need later on. But for now I can do Ctrl C, Ctrl V, and use the same node down here. It gives you close to 2000 items. Next step, we want to shuffle these two lists. Let's go search for shuffle. Connect here, and let's compare input and output. You can see there the input is a bit regular. It repeats the same list from 4 to 4500. That's one list there, and then the same list gets copied below from 4000 to 4500. That's the second list, and then the third one appears, and so on. In here, after shuffling, you can see the items, they don't follow the same order anymore, and that should be better for our randomization of the facade. We can now Ctrl C, Ctrl V, and do the same thing here. Next step, I want to make sure we are not getting more than 173 items from here. Let's do list.chop. Get this list to there, and the length we need will be 173. Run this now, and you can see now it gives you several smaller lists, which are smaller sections from this big list over here. If I go and do another count node after this, you can see straight away that you have 6 lists. If I expand just the first one, it has 173 items on it, exactly what we need. Let's do the same here now, Ctrl C, Ctrl V. It's time now to set those values for our balconies. Let's search for set parameter by name. The elements to be affected will be those balconies items there. Parameter value will be from here, and parameter name will be overhang. I can now connect that to here, and let's say we run it to see what it does. If I look into the top view first, you will see they now have the same overhang amount. Let's run this, see what happens. Straight away you see now, much better looking effect, because now those overhang amounts are varied from balconies to balconies. We cannot do the same for param 1. If you try to do that with the same node, however, it will fail. Let me show you. I can just copy those two and change this to param 1. This time the values will come from here. So in theory that should work, but if I run it now, it gives an error. This is because this node here, it doesn't work on normalized curve parameter, and that's what our param 1 needs. To do this, I will need to have a custom Python node, and don't worry because this node will be included in the script you can download from the description. For now I have copied it from elsewhere. Let me just right click here and add in a Python script node. Open it now. I can do Ctrl A and Ctrl V to paste my script in. Click Save Changes, and I can now add 2 more input ports. This one uses the same inputs like that one over there, so I can now just transfer them over like that. Delete this now, and let's try to run it. Well, that didn't do very well. Let's see. There's an error here, and that's because I didn't remember to section out this list. If you remember, in here I have several small lists, 11 of them to be exact. I just need the first one to go into this input port. Let's now do deconstruct and get this to there. This node does nothing else than separating the first list from the other list below it. We can now fit this to there and rerun the definition. Excellent. You can see now that's a much better looking facade. And because we've done this with Dynamo, it happens across the entire file. To see this in a project, I can now go to New Project, go back to the mass family now, and load this into project number 4. I can now place it right here, and then go check it out in 3D. Here we go. If I go here and make a new camera view, you can see that's the same design we have in the example project at the beginning. This one here. Now of course there are other things coming to play here, such as this curtain panel family. Or if you go to 3D, also those walls by face or floors by face. Everything was created based off that mass. These are more basic mass modeling skills, so let's cover them in another video. To see that new lesson and more tutorials like this coming every single day, make sure to subscribe to this channel. For now, get the Dynamo script from the video description. Practice creating this very interesting facade, and I'll see you in the next lesson.